Alrighty, everybody. In this video, we are going to talk about probability, how to find probability in general, and then we're going to talk about theoretical and empirical probabilities, what's the difference, and how to find each one. So probability is the likelihood of an occurrence. Alrighty, so it's going to be a ratio, which is a fraction. It's a ratio of favorable outcomes to total number of outcomes, and we can express that as a fraction, as a decimal, or a percent. So to find a probability, we are going to put the number of successes, how many items are we looking to happen, over the total number of items, or how many outcomes can happen from whatever we're doing. I know it's a little confusing, but let's take a look at this example. A container has 40 colored marbles. 8 of the marbles are blue, so we have 8 are blue, 13 are yellow, and 10 are red. Alrighty, and let's not forget the green ones. 9 are green. So we've got these different colored marbles in the bag. We mix up the marbles, and one of them is selected at random. What is the probability that we select a green marble? So when we write this down, we are going to say, we do a big P. That big P stands for probability, and we're going to say the probability of what? Probability of a green marble. So what we are going to do is we're going to put the number of green marbles over the total number of marbles. All right, so when we look at this, we need the number of green marbles, and we need the total number of marbles, which is right there. There are 40 colored marbles. So when I do green over total, that is 9/40. And that is a great way to write that as a fraction. I can also write it as a decimal, which would be 0.225, or I could write it as a percent, 22.5%. Boom, easy peasy. That is a probability. So there are a couple rules from probabilities. Probabilities must be greater than or equal to 0 or less than or equal to 1. So the probability of any event needs to be between 0 and 1 inclusive. No negatives, and I cannot be bigger than 1, because the probability that an event is 1 is a certainty. This means my event must happen. If a probability is 0, that's an impossibility. This event will not occur because this is impossible. What is the probability on a 6-sided dice? I roll a 7. 0. So probability of event is 0.5. It's equally as likely as unlikely to occur. So a lot of people call this a 50-50 proposition. Flipping a coin would be a 50-50 proposition, or a 0.5 probability. Probabilities that are closer to 1 are more likely to happen, and probabilities that are closer to 0 are less likely to happen. So if you look at that as a segment with 0 and 1 and 0.5 in the middle, when we go this way, we are more likely to happen. And when we go this way from 0.5, we are less likely to happen. Doesn't mean impossible. It just means that to the right of 1/2 is more likely to happen than to the left of 1/2. So which event is more likely to occur? If we look back, the probability of green or the probability of yellow? Already, well, we said the probability of green. We said that probability, if we look back, the probability of green was 9 out of 40, which is 0.255. So I'm going to write them both down. We said 9/40, which is 0.225. And it's that number because there are 9 green marbles. There are 40 marbles in total. So let's figure out the probability of yellow. So the probability of yellow is, of course, going to be the number of yellows over the total number of marbles. Total number of marbles. So let's look back. How many yellow marbles are there? There are 13 yellow marbles, and there are 40 marbles. So that is going to give me a probability. Well, I can see 13/40ths is bigger than 9/40ths. And if we do it as a decimal, we can see that it's definitely bigger, 0.325. So which is more likely to occur? More likely means closer to 1. So green is over here at 0.225. You know, why don't we make that? That is the probability of green. Green would happen right here. Well, yellow is going to be 0.325. So 0.325. So which one is more likely to occur? The probability of yellow is going to be more likely. It's closer to 1. It's closer to 1 than green is. So boom. So if I want to look at these, which of the following could be a probability? So if you look back at our rules, all probabilities need to be between 0 and 1. That is our big rule for probabilities. Every probability can be written as a decimal or a percent, so that's okay. So I look at this 0.2. That, let's see, it's a decimal, and it's between 0 and 1. Perfectly fine. 3/4. Yep, good probability. Not 17/16. This is bigger than 1. It's larger than 1 because the numerator is larger than the denominator. 0.25%. It's really small, but it's still between 0 and 1. Negative 0.84. This is not a probability. We are smaller than 0. Probability can never be negative. 0 works. 16.3% works. 134%? Nope. We are larger than 1. Because 1 equals 100%. 1 as a decimal or a fraction is 100%. Theoretical probability is what an event should be. I don't know if it actually will be this way, but if I roll a 6-sided dice, what is the probability that I will roll a 3? So what I am asking, what this question is asking, on a 6-sided dice, how many different ways can I get a 3? And then how many sides are there? So on a 6-sided dice, there is one way to get a 3. We could get a 3. And the probability that I roll a 3, there are 6 sides on that dice, so it is 1/6. Boom. And you could turn that into a decimal or a fraction if so asked. So what's the probability that I'm going to roll an even number? So to find this probability, I am going to put the number of evens over the number of sides. So on a 6-sided dice, the even numbers are 2, 4, and 6. And the sides, there's a 1, 2, 3, 4, 5, and 6. So there are 3 even sides. There are 6 sides, which is a probability of 1/2. Equal probability of getting evens or not evens. Now, experimental probabilities are I am actually going to do an experiment, and then we are going to see what that experiment shows us. Sometimes they will call this empirical probabilities. I do believe that's what I called it in the learning objective. So we roll a 6-sided dice 60 times. This table actually shows the results. So if you were to add all of these numbers up, you would get a total of 60 rolls. This is an empirical or an experimental probability because I actually did it. So how many ways did I roll a 3? And how many rolls were there? Because I actually rolled it, we're going to say the number of rolls. So there were 12 3s. We rolled a 3 12 times, and we did 60 rolls. So 12 divided by 60, when I reduce that, is 1/5. So the probability I rolled an even is the number of evens over the number of rolls, because again, I want the experimental probability. So our evens, we rolled 6 2s, we rolled 11 4s, and we rolled 14 16ths, or 14 6s, sorry, 14 6s, and we made 60 rolls. So let's see, when I add 17 and 41, 17 plus 14, that gives me 31. So we rolled 31 evens and we made 60 rolls. That is the probability of rolling an even number. And it's by actual rolling, so that's why it's an experimental probability. So if we pick from our numbers 1 through 8 and we did this 130 times, what is the probability that we get an even number? Well, it's the number of evens over the number of picks, or the number of trials. So we got an even number, 2, 4, 6, and 8. That's 22 plus 24 plus 18 plus 7 over 130. So 71 of our picks were even, and there were 130 trials, which leaves me with 71 1/30. All right, what's the probability that we get a prime number? Now, we've got to watch out for words like this. Primes are numbers that only divide by themselves and 1. So nice math word. So the probability I get a prime is going to be the number of 2s plus the number of 3s plus the number of 5s, these are my primes, plus the number of 7s over the number of trials. 1, 2, 3, 5, and 7 are my primes. 1 is not prime. So 22 plus 17 plus 24 plus, oh, not 24. Nope. That's a 4 plus 12 plus 15. All right, so I find the sum of the prime numbers. How many times did I pick a prime number? 66, and there were 130 picks. So when I divide that and I reduce that fraction, I get 33 out of 65. Boom. All right, so this video is running a little longer than I wanted. So to finish this up, we are going to go ahead. Oh, let's do this one. What's the probability I get a number smaller than 10? Well, so it's the numbers that are less than 10. So that's all the numbers 1 through 8. How many 1 through 8s did I get? And how many total numbers were there? Well, that's all of them. Every number on this list was less than 10. So that is a certainty. If I am picking numbers 1 through 8, I must pick a number smaller than 10. All right, so we're going to finish up this lesson with the other videos, and we will go from there.